Alright, welcome to this video. We're going to be reviewing all of Unit 6 polynomial functions. Let's get started. Here's the overview for this lesson. We're going to briefly cover all of the 7 lessons and kind of talk about how are they interrelated and what do they have to do with each other to refresh your memory and prepare you for the upcoming tests. So we talked about in this unit polynomial equations, which are equations of this form. I know that's just a complicated looking math expression. All it means is we're talking about equations like x cubed plus x squared plus 1 and x to the 1/2 equals 5. So on and so on. Those are all examples of polynomial equations where you have an x and then you have some number to the power and potentially you have a number in front, a coefficient. We talked about multiplying them, subtracting them, adding them, dividing them, which also we talked about factoring and simplifying, which is a way of dividing. And then we talked about solving equations with them. So in this lesson, we're going to briefly cover all the 7 lessons and you'll get to refresh your memory on how we did these things. Okay, so lesson 1, we talked about adding, subtracting, and multiplying polynomials. The big idea here is like terms. You need to combine like terms. So let's start if we just added these two expressions. 2x squared plus 4, then plus 3x squared minus 2x. Well, we got to combine 2x squared and 3x because they're like terms, and then the other ones are going to stay by themselves because they're not like terms. 2x plus 3x squared gives me 5x squared. Then I've got a minus 2x there and a plus 4. So that's my answer if I were to add them. What if I were to subtract? Let's see what we would get there. So 2x squared plus 4 minus 3x squared minus 2x. Okay, again, 2x and 3x, 2x squared and 3x squared, now they're subtracted, will give us negative x squared. And then the other two terms, we got a minus here and here, so that's going to turn to a positive. So plus 2x, and then we've got a plus 4 there. So that's my answer if I subtract. And then what if I multiply? Well, when I multiply, I'm going to have to do some foiling here. 2x cubed plus 4, sorry, 2x squared plus 4 times 3x squared minus 2x. Let's factor this out. 2x times that, 2x squared times negative 2x. That's going to give us 6x to the 4th minus 4x cubed. And then I do the same thing, 4 times this, and then 4 times that. So that's going to give me 12x squared minus 8x. And that's going to be my final answer. Alright, in lesson 2, we talked about dividing. We already did add, subtract, and multiply. Let's do dividing. So to divide these two expressions, we're going to do it like long division we learned how to do in middle school. So we asked the question, what do I need to multiply by x to give me x squared? And that's just going to be x. So then I do x times x gives me x squared, and then x times 2 gives me 2x. Now from there I subtract, these would cancel, 5x minus 2x is going to be 3x, and then I bring down my next term and I do it again. What do I need to multiply by x to give me 3x? That's going to be 3. Then I do 3 times x gives me 3x, 3 times 2 gives me 6, those cancel, and I get a remainder of 0. So this is going to be my answer right here, x plus 3. Alright, in lesson 3 we talked about factoring polynomials, so now a different type of division in quadratic form. So we did a simple substitution here, we let u equal x squared, and we rewrote this as x squared plus 5u plus 4. Now we can solve this using the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. Your a here is 1, your b is 5, and your c is 4. When you do that out, you'll get x squared, sorry, not x squared, you'll get u plus 4, and then u plus 1. Now we know what u equals. U is actually equal to x squared, so let's rewrite this as x squared plus 4 and x squared plus 1. Now if you had a sum and difference I mean, a difference of squares, you might have to simplify more, but we don't have to do that on this question. This is our final answer. All right, lesson number 4, factoring polynomials in a different way, now by summing difference of cubes. Let me just quickly remind you, if we have a cubed plus b cubed, that's going to equal a plus b times a squared minus ab plus b squared. I'll provide these formulas for you so you don't have to memorize that. But let's use this to solve this question. My a here is actually going to be 4y, because 4y cubed is 64y cubed. My b is going to be 3, because 3 cubed is 27. Then I need to figure out what is a squared, so I can plug it into the formula. A squared is going to be 16y squared. What is b squared? 3 times 3 is 9. And then what is a times b? A times b is going to be 12y. 4y times 3. Then I put it all together, and I get 4y plus 3 times a squared, which is 16y squared, minus ab, which is 12y, plus b, which is plus b squared, which is 9, and that's my answer. Okay, then we learned the final way to factor, which is factoring by grouping. So let's do that here. First, we group the first two terms and the second two terms. Then we ask the question, what is the greatest common factor of these first two expressions, 10v cubed and 18v squared? Well, they both have 2 and they both have v squared, so I can pull that out. And I'm going to get 2v squared. And then what do I need to multiply by 2v squared to give me 10v cubed? It's actually going to be 5v. And then similarly, what do I need to multiply by 2v squared to give me 18v squared? Would be 9. Over here, the only thing that comes out here, the greatest common factor is going to be 1. So I'm going to rewrite this here as 1 times 5v minus 9. Now I got this term and this term match, so I know I did it right. And I rewrite it in the following way. 5v minus 9 times 2v squared plus 1. That is my final answer. Okay, lesson 6, rewriting radical expressions. So first we need to rewrite this as a fractional exponent. So in the following way, 1/2. Then I'm going to factor that to both terms. Distribute it. You get 4 to the 1/2 times x plus 5 to the 5th power, all that to the 1/2. 4 to the 1/2 is going to be 2, but 5 times 1/2 does not work. This right here is not going to give me a whole number. So I need to split up that x to the 5th, and I'm going to get x plus 5 to the 4th times x plus 5, and then all that is to the 1/2. Now I distribute again. 1/2 times 4 is 2, so I get 2 times x to the 5th squared, and then this term right here has to stay under the radical, so I get the square root of x plus 5. That is my final answer. Last lesson, solve equations with rational exponents. First, you gotta raise both sides to the opposite power that cancels out the fraction, so in this case 2/3, and those two will cancel, and what I do to one side I have to do to the other. I get x plus 5 on the left, then 125 to the 2/3. First I gotta do the cube root of 125, which is going to equal 5, and then I gotta square that. And that equals 25. So I get 25 here on the right, then I subtract 5 on both sides, and that leaves me with x equals 20. Alright, I know that was a lot, but that was a brief refresher of all the things that we've covered in this unit. Here are the IXLs for those lessons, so go back over those, practice them, prepare yourself for the test, which will be via Google Forms on the Google Classroom. If at any time you need help, please send me an email, or you're welcome to join me during my office hours on Zoom. Alright, best of luck.